All right, this is lesson 5-1. We're talking today about congruent triangles. We've talked about congruent angles already this year. We've talked about congruent segments. And the word congruent simply means having the same measure. Well, there's only one way to measure a segment, and that is by its length. And yes, there are different units of length. We can talk about inches versus centimeters versus miles, but they're all just units of length. And there's only one way to measure an angle, and that's by its number of degrees. But there's lots of ways to measure triangles. When you talk about two triangles being congruent, what does that mean? That means they have the same measure. There's lots of measures in triangles. Does that mean all the measures are the same? Only certain measures are the same? Here's two triangles right here on the screen. Believe it or not, they have the exact same area. That's one way to get a measure of a triangle, is by the area. I'm sure that's a concept you're familiar with, although we're going to study it in much more detail later this year. These two triangles have exactly the same area, right? But this triangle down here has got a right angle, clearly, or at least it appears to. This triangle clearly does not seem to have a right angle. Are these triangles congruent because they have the same area? Or what about these two triangles down here? These two triangles have the same perimeter, which I'm sure is another idea you're familiar with. The perimeter of not just a triangle, but any polygon, is the distance around. In other words, add up all of the side lengths. And again, believe it or not, I have constructed these triangles in such a way that if you added up the side lengths of this one on the left and then this one on the right, the totals would be the same. Okay? Does that make these triangles congruent to each other? Well, the answer in both cases is no, as you probably suspected. So what does congruent triangles mean? Well, here's a definition right here at the top of this notes handout, which I hope you have printed out. You're taking notes along with us as we're going. Stop the video if you don't have it out, and you can have it out. Okay? To say that two triangles are congruent is to say, this is the definition, that every side or angle from one triangle is congruent to a corresponding side or angle from the other. Okay? Every side from one triangle has a matching side, so to speak, from the other. And every angle from one triangle has a matching angle from the other, so to speak. Okay, here are two such triangles. All right, and I've worn a white shirt today while I'm doing this, so you can, when I hold these triangles up, you can see them clearly. All right, these two triangles are congruent to each other because I can find a way to fit one of them exactly on top of the other, where all of the angles match up and all of the side lengths match up. Okay. Or pick one triangle. In this green triangle, this angle up here, this very acute angle, which seems to be about 30 degrees, has a matching or a corresponding angle in this triangle, 30 degrees. And this angle over here in this green triangle, which appears to be about 60 degrees, has a matching angle in this pink triangle, 60 degrees. This angle here seems to be a right angle, and that angle there seems to be a right angle, and they match up. And not only do all the angles match up, but all of the side lengths match up perfectly also. Okay? So these triangles are congruent triangles. And it doesn't matter which way they're facing or pointing or anything like that. They are congruent right now. They are congruent right now. They are congruent no matter how I hold them. Okay? That's what we mean by congruent triangles. So here are two triangles, and they have lots of congruent marked pairs in them. And right now, all I want you to do is pause the video for a moment to name this triangle on the right in 6 different ways. I've already given one name for the triangle. I'd like you to come up with the other 5. All right, so hopefully you've taken the time to do that now. Triangle MRV is one name. Triangle MVR R, that would be a different name for the same triangle. And those are the only two ways I can begin the name of the triangle with the letter M. So I'm going to choose a different letter to start with now. I'll choose the R, and I can do triangle RVM or triangle RMV. And there's the only two ways I can name this triangle starting with the letter R. So I've used up the letter M as the first letter. I've used up the letter R as the first letter. And now I'm going to use the letter V, triangle VRM, and triangle, oops, that was not an M. That should be triangle VMR. Let's go get the eraser, VRM. That's supposed to be an M. Here's the 6 different ways that I can name this triangle here on the right. But in mathematics, there is only one correct way to finish this statement with a name of this triangle on the right. Triangle JTQ is congruent to this triangle over here. But when we write that out, there's only one of these 6 names for this triangle that is the correct way to finish this sentence now. Do you think you know which is the correct way to finish it? So here's a clue. The letters have to match up. The order of the letters matters. Okay. Yeah, okay, I've heard it. So triangle JTQ. Take a look at angle J or point J in this triangle. That angle's got a triple arc mark in it. Right? Where's the angle that's got a triple arc mark in this triangle over here? It's the M. So this triangle name must start with an M. And then if you look at the T, which comes next, it's got a single arc mark in it that corresponds to, okay, to use that word, corresponding. We use that a lot when we're talking about congruent triangles. Corresponds to point R or angle R. And then finally, the Q corresponds to the V. Oops, I was going to draw a Q there. That should be a V. Okay, that's the correct way to finish this statement. So if you're reading a congruence statement about 2 triangles and you don't know anything about what the triangles look like, you can tell from the written statement, a statement like this one here, which angles correspond to each other and which sides correspond to each other. You can tell from the statement. So let's look at an example like that. Suppose I tell you right here, the triangle WGA, which we can see is congruent to triangle PHF, which I haven't drawn for you. And I don't plan to draw it for you. Okay. I mean, it's hidden somewhere. Maybe it's down further on this page or on the next page, but it's there. Okay. From this statement, what segments are congruent and what angles are congruent? Well, again, we can tell from the order of the letters. In triangle WGA, for instance, there is a segment WG. That's one of the sides of the triangle. That must be congruent to a side from triangle PHF. But can you name the side? Right, PH. Okay, because W and G are the first 2 letters of this name. P and H are the first 2 letters of that name. Okay. For that matter, WA, which is this side of this triangle here, would be congruent to which side from triangle PHF? Right. PF. W and A are the first and third letters. P and F are the first and third letters. And finally, there is one more side in triangle WGA, and that is side GA. Right there, second and third letters, that would be congruent to side HF. Okay. Now, as it happens, in this triangle WGA, there are other segments, right? I mean, there's this segment here, WI. Is that congruent to anything from triangle PHF? Well, I don't know any other points in triangle PHF. In fact, I don't know if triangle PHF even has another line drawn through it like this one here or any other points on it anywhere. And even more than that, suppose I did have a picture of triangle PHF. Suppose it was right next to triangle WGA. And I had another segment drawn here across the middle of it, and I called it, I don't know, OX. Okay. You cannot say on the basis of this statement that anything having to do with points I, M, O, or X is congruent to anything else. You cannot say that segment IM is congruent to segment OX. Those are not considered to be sides of these two triangles. IM is not one of the sides of triangle WGA. Okay? So we can't say anything about segment IM or OX. What about the angles? Okay? The angles, we have an angle WGA. That would be this angle down here. But again, I'm going to go erase this picture because I want you to learn that sometimes the picture can fool you and you want to rely on the order of the letters in the name. WGA, WGA, that would be congruent to angle, what, PHF. Angle WAG, that's first letter, third letter, second letter, would be congruent to first letter, third letter, second letter, P, angle PFH. So far I've named angle G, angle A, and now I need an angle with the W in the middle, so angle AWG will do, and that is AWG, third letter, first letter, second letter. So in triangle PHF, I got to go third letter, first letter, second letter, FPH, congruent to angle FPH. Okay? And there are no other angles that we can say are congruent. We cannot say anything, for instance, about this angle here, angle WIM. Again, even if we had a picture right here, okay, we cannot say that this angle is congruent to this angle. Those are not what we consider to be angles of, well, this angle is not an angle of triangle WGA. Right? I know this angle is being formed in part by some of side WG, but not the whole side WG. When we talk about, we use this word a lot, parts of triangles. Okay? That word part means a whole part. Okay? Which is a little odd to be saying. All right? A whole part. A whole side of the triangle or a whole angle of the triangle. If I'm talking about, let me just draw some other random triangle here, A, B, C, and then let me draw a line coming out of point B over here to point G. If I'm talking about triangle ABC, this angle right here is not a part of triangle ABC. It's a part of triangle ABG, but it is not a part of triangle ABC. All right. This angle here is what we consider to be a part of triangle ABC. And then so is this angle, and so is this angle. This side is a part of triangle ABC. This side is a part of triangle ABC. This segment right here is not a part of triangle ABC. This whole entire segment is. Okay, let's move on. This is the last example problem we have for today. Might say a couple comments about the homework, and this video is done. Got another proof to do. Lots of proofs in tonight's homework. 8 of them, if I remember correctly. Okay. In this proof, you have been given a new piece of information, a piece of information that was not given in any of the proofs from the previous homework assignment. And that piece of information is that we have 2 congruent triangles. Triangle MAC congruent to triangle RDB. If you're really alert, you might notice that I haven't said in this picture that I haven't written this phrase here, diagram as given, which was present in every single one of the proofs in the last homework assignment. We're just going to assume that the diagram that's given with the problem is part of the problem. I'm not going to write that out anymore in any of the proof problems, okay? But you should assume that the diagram is part of the problem, okay? So that's not going to show up anymore. So we're given this diagram and the fact that triangle MAC is congruent to triangle RDB, okay? And in this particular problem, I'm also telling you what I want you to prove specifically. In the last homework assignment, I was not telling you anything specific to prove. I was just asking you to, prove something. What can we conclude on the basis of some statement that I've given you? But now I'm telling you specifically what I want you to prove. Okay. And so the statement here in this proof is like, you don't even have to think of what that ought to be. I'm telling you what it ought to be right here. I'm giving you half of the answer to this proof problem. I want you to prove that angle MCA is congruent to angle RBD. Now, if you've been paying attention to this lesson so far, you may be thinking to yourself, what is there to prove? The triangles are congruent, so the angles are congruent. And you might have been thinking that in the last homework also. You might have felt like you weren't really proving much of anything. Okay? If I tell you that a point is a midpoint of a segment, and I ask you to prove something, and you write, well, I got 2 congruent segments here, that may not feel like you're accomplishing much of anything significant. And I would have to sort of agree with you there. When I tell you a point is a midpoint of a segment, and you write out a proof that, there's 2 congruent segments here, that's not much of a mathematical accomplishment. But when you're learning to write proofs at the very beginning, the geometry problems have to be very, very short and simple. And it may not feel like you're proving much of anything, because what you're learning when you're first learning to do proofs is how to properly write proofs. You're not learning more complicated geometry. Okay? If you're trying to learn more complicated geometry and how to do proofs at the same time, it's going to be very confusing. Okay? So we keep the proof problems very, very short in the beginning. So short that it probably often feels to many of you like you're not even really proving anything. But you are, okay? Because a proof, remember, is, as I said in the previous video, just the explanation for why you come to a certain conclusion in geometry, okay? And the explanation here, remember, I like them all to be written as if-then sentences, okay? So we're going to start this with if. And what follows the word if must be a statement on its own, a complete English statement. And in proofs, this hypothesis of this if-then statement, remember that's what we call the first part, the hypothesis or the condition, must be something that we already know is true in this problem. It must be something that's already written in the statements column in a prior statement. Okay. So if you had no idea about proofs, if you hadn't even done the last homework assignment, hadn't watched the last video, based on what I'm saying to you right now, you might be able to tell me what should be written in this blank here, because it's got to be a statement that's already written in a prior statement in the statement column of this proof. Well, there's only one thing that's already written so far, right? We only have one statement so far before statement number 2. And that's this statement right here, which is telling us that there are 2 congruent triangles. Now remember, in the reasons column, we keep our reasons general. We don't name specific things. We just keep them general. This is saying triangle MAC specifically is congruent to triangle RDB specifically. In this reasons column, we just say if triangles generally. We don't name the triangles. We just say triangles in general. If triangles are congruent. Okay. Which, watch what I'm going to do here. I'm going to highlight this, and I'm going to highlight this. You're going to see those highlights in all of the homework problems when I have completed them. You don't have to do that. You don't have to do that to get credit for the problem, although it might not be a bad idea for you to do that to make sure that you are writing out the proofs correctly. Every time you write out a reason, highlight the hypothesis of the reason and highlight a prior statement in the statement column to match this reason with a prior statement. Okay? You don't have to do it for the credit, but it might not be a bad idea. And then the conclusion. If triangles are congruent, then here's the sentence. There, again, we want to keep this general. Okay? We want this conclusion to match this new statement. And this new statement is telling us that there are 2 congruent angles. And it's naming the congruent angles. I don't want to name angles here. Okay? I just want to say in general, these triangles corresponding Now, I could say corresponding angles are congruent. And if you said that, I would give you full credit. Okay? It's a generally worded sentence. It matches the statement in the statement column. And it's true that if triangles are congruent, then their corresponding angles are congruent. Okay? But what you're going to see in my answers is not the word angles. You're going to see an even more general word than that. Okay? You're going to see the word parts. Okay? Boy, that doesn't look good at all. Let me erase that and write it one more time. Parts, corresponding parts. Okay? And that word parts is an even more general word than angle. It can refer to angles, or it can refer to sides. Okay? So that word covers me whether I want to prove that 2 angles are congruent, or suppose I had asked you to prove in this problem that segment MA is congruent to segment RD. Okay? Then I could have used this exact same reason, worded this exact same way, because again, the word parts can refer to sides of the triangles as well as angles of the triangles. The only difference is this second statement here would not be this, it would be this, whatever I've asked you to prove. Okay? So page 2 of the notes is just now an updated list of reasons that you can use in proofs. And here's the new one down here. It's the only new reason we have. You've got 8 proofs in tonight's homework. I think maybe half of them, okay, are going to require you to use this new reason so that you get used to using it in the appropriate places. And then the other half of the proofs are going to use some variety of these reasons here, which hopefully you got to practice using in the last homework assignment. Okay. Um, the homework might look rather long because I think it stretches out over 4 pages, but that's just because it takes a lot of space to write these problems. It doesn't really take a lot of work to do these problems, so don't freak out over what might appear to be a really long homework assignment. I think that's all I wanted to say in this lesson. So if I forget anything, I'll talk about it in Zoom class. All right, get after the homework.